the ball is framed, the unicorn does not jump back, and the ball is just going up and down. The unicorn does not jump back because if you look at the distance between the boy and the unicorn, the boy is running toward the right. So in the freeze frame, even though the unicorn is jumping back to the original position, but after 2 seconds, the boy is closer to the unicorn. So in the boy's frame, it seems like the unicorn does not jump back to the original position. Okay? So to describe motion, we need to figure out the x and y position of the objects at all the time. Let's say we look at the motion of this baseball in a trees frame. So in the trees frame, I want to look at the x position of the baseball. I write x ball for x position of the baseball. The unit I'm using here is meter. It's just a common unit we use. And I also need to describe the y position of the baseball, just like I need to give you G string and Z string in 2 numbers. And I just need to do that for all the time. For t equals like 0, 0.1, 0.2, blah, blah, blah. Let's just do 0.5 as our time interval. So to do that, I just look at what's happening. So at t equals 0, in a trees frame, the baseball has 1, 2, 3 horizontally. So the x of the ball is 3 at t equals 0. Any question with that? Okay. Just 1, 2, 3. So it's 3. For the y position, it's just on the horizontal axis. So the y position at t equals 0 is 0. Right? So we just keep doing that for all the time. 0.5, the ball is 1, 2, 3, 4. The x position is 4. For the y position, it's kind of between 1, 2. It's kind of between 4 and 5. So right now, because I'm the one that draws this image, I know what I'm drawing. I can just zoom in on my computer and count it in better detail. The exact y position of the ball at this time is 4.75. Now when it's your turn to do it in the homework, I will give you enough information so you can know exactly what the position is. But the idea is the same. You just count which grid line or which grid point it is at. And you can do it approximately. You don't need to be very accurate. Okay? And we do it again. This is 5 in x. Blah, 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 blah. It looks like 7. And at t equals 2, the x position is 6. And the y position is something in the middle. The exact value is yeah, I skipped one. Yeah, I skipped one. This is 1 second, so it should be 6, 7, and here is 6.75. This is 1.5. Yeah. So at t equals 2, the x position of the ball moves to the right one more. It becomes 7, and the y position becomes 1, 2, 3, 4. So here is how I describe motion. I just write down the location of the ball at all the time, and I'm describing motion. Okay? Now, are you guys familiar with function? I can use that? Nice, good. So, to describe motion, I just need to know where the location of the object is at any time. So, it's like if someone asks me where the ball is at t equals 0.5, I give him a pair of location. Someone give me a time, I give them a x or a y. Input something, output something. That's function. So the key to describe motion is to just write out the x x position and y position as a function of time. This is not sine or cosine, so the thing inside the function can have a dimension. This means that the thing is a function of time. It looks like I'm writing x equals x, but here the parenthesis is not multiplication, because if you want to multiply x with t, you don't need the parenthesis. So if you have this parenthesis, usually it means that the thing in the front is a function of t. And this is just emphasizing that this thing is a function of t. Okay? So the key to describe motion is to write x as a function of time. And in this notation, the x of the ball at t equals 0 is 3, because the x of the ball at t equals 0 is 3. Any question with this notation? Function is you input the time and then you output the thing. You input d, x is 3, so x at t equals 0 is 3. Okay? You can keep doing this. X of the ball at t equals 0.5 will be 4. You can keep doing that and you are describing motion, but it's tedious, right? You have to write a bunch of stuff. You see a bunch of symbols and numbers, but you don't really see what's happening. So a better way to describe a function is to plot it. I can plot the x position of the ball with respect to the time. This is not a coordinate system. This is not y and x. This is x and time. They have different dimension. X is length, t is time. It's not a coordinate system, okay? It's just a plot. So at t equals 0, the x of the ball is 3. So I can put a dot over here. When t becomes 0.5, it becomes 4, and then it keeps going up. This is what I mean by plotting the function. You guys done that before? Plotting function? Any question? Okay. So even though this is just 5 dots, this is because I only show you like 5 times. In reality, you can just keep counting time. So you can keep doing this. Imagine you have a high-speed camera, so you can look at the location of the ball at any time, and at the end you get a line. Okay, so that's what we call a xt plot. You just plot the x position of something with respect of time. Now, if you look at the xt plot in the trees frame and the boys frame, you see the plot looks different. Let me remind you what the two different frames looks like. In the trees frame, the ball is flying to the right, so the x position will increase with time. But in the boys frame, when the ball goes to the right by 1 meter, the ball is also running to the right by 1 meter, so their horizontal distance doesn't change, and the ball is thinking that the ball is just flying up and down. So in the boys frame, the x position of the ball will not move, and you see this graph, which the x position of the ball in the trees frame looks like this, but in the boys frame, it's just a constant value, 3, for all the time. Do I need to go slower? Okay. And on the right hand side, this is just for the y position of the ball. Even though the x position looks different in these two frames, but vertically, the ball is always flying up and down in both frames, so they see the same yt graph. And here we can clearly see that the motion is different in terms of function. if we just keep writing numbers, it's hard to see what is happening. So if we plot it, we can clearly see that the motion looks different. I mean, this looks the same, but this is different. The difference is the slope of this straight line, right? They all start at 3, but the slope, which is the amount of x you increase in a amount of time. So let's call this delta t. This triangle is delta. Delta t means the increase of time, and delta x is the increase of x position. Have you heard delta before? Really? Wait, when? How many of you took physics before? So you learned it in like high school or something? How many of you never seen delta before? Really? Okay, fine. I'll just go through it real quick. So the slope of this line will be delta x divided by delta t. It is the ratio between how much the x will change compared to how much the time has. It is the rate of change of the x position. You can see that this slope is different for different frames, so this slope is important. And this is what we call the x velocity. Similarly, the y velocity will be the change of y divided by the change of t. Okay? So this is what you can do for a line that is not straight. When we look at the x position of the ball, it is a straight line, so the slope is basically the same at all times. But when we look at the y position of the ball, it is going up and down. And the slope depends on which point you are choosing to calculate the slope. The yt graph of the ball looks like this. The y position increase in the beginning and then decrease. So the slope is the increase of time. If this time corresponds to some time called t1, this one is t2, then the amount at the time change is t2 minus t1, right? And here, the y position corresponding to this t1 is y at t1. It is the y position at t1. And that at here is y at t2. Okay? So the difference here is y at t2 minus y at t1. Now, in this case, the y velocity is y at t2 minus y at t1 divided by t2 minus t1. And it looks like the choice of t1 and t2 will both affect the y velocity you get, and that is true. If you choose different t2, in this case t1 is always 0.5, and you choose t2 to be here, here, or here, the slope you get will be different. The y velocity you get will be different. But let me do a small